When a sphere of radius of falls down in a fluid of coefficient of viscosity neta1 and density d1, it attained the terminal velocity v naught, and when the sphere moves up in a fluid of coefficient of viscosity neta2 and density d2, attained the same terminal velocity v naught. The difference between the density of the fluids is proportional to.
Alright, let's get into the equations now. Right here, our first equation, the weight downwards equal to the upthrust plus viscous force, and the viscous force Fv equals 6 pi eta Av. Here A is the radius of the sphere, and the terminal velocity V equals 2 A squared G sigma minus rho 9 eta. Here sigma is the density of the sphere and rho is the density of the liquid. Right, you should know these equations when you are doing this question. So let's apply the values here. So here we have two different scenarios where the sphere goes down and the sphere goes up. For the sphere to go down, the density of the sphere has to be greater than the density of the liquid, and in the second scenario, you know, the density of the liquid is greater than the density of sphere, right? So in the question they are asking us to find d1 minus d2, right? So to achieve that, let's subject d1 from the equations, right? So here I can get 9 eta 1 v naught divided by 2a squared simple g equals t1 minus rho. So here I can take this minus rho towards the other side, so then I get rho. Right, first equation. In the second same method, again we can take 9 eta 2 v naught divided by 2a squared g. Here we get rho minus d2. So here we need to find d2. So what we have to do is we have to take d2 to this side and this to the other side, right? So again we take d2 equals rho minus 9 eta 2 v naught divided by 2a squared g, right? So we have our second equation. So what we have to do is we have to subtract 1 from the second one, so it's d1 minus d2. So 1 minus 2, so from this side we'll be getting d1 minus d2. So you can see this row and this row will cancel off, and I'm getting 9 eta 1 v naught over 2a squared g minus minus plus 9 eta 2 v naught 2a squared g. So here you can see now 9 eta 9 v naught over 2a squared g is common. So here I get eta 1 plus eta 2, right? So they are asking the proportionality d1 minus d2 is proportional to, let's find the answer, n1 plus n2. Right, students, if you think this is helpful, share it with your friends, study together and win together.